Hi class. I'm doing this video to help you find the local minimum and local maximum of an equation. So from the graph, okay? And just kind of, this video is gonna help you kind of understand what a local minimum and a local maximum are. So for this problem, it says the function f of x equals 2x cubed minus 27x squared plus 48x plus 11. And then it says it has one local minimum and one local maximum. And then it says use a graph of the function to estimate these local extrema. Extrema are your max and min, or where it the graph kind of hits a maximum, it then kind of starts going back down. It's a local maximum, local minimum. So I just explained to you what a local minimum and a local maximum are. So let's say I have like an equation, and let's say it goes up and it goes down, like a lot of these, like a cubic here. This is a cubic equation, so it will go kind of go up and down. So this spot right here would be your local maximum, because it is in its own little neighborhood. It is the maximum value of the function in its own little neighborhood here. And here, basically the top of any hill is a local maximum, and the top bottom of any hill is also a local minimum. Okay, so that's just what we're looking for. So to find the local max and local min, we have to look at the graph of this, and I'll show you how to graph that. Let's see, and using a program that can help you graph. This function has a local min, okay, but wait, they also want, not only they're asking for two things here, where does the minimum happen? So x equals at what x value, what value along the horizontally does the maximum happen, right? So let's just say this is 0, 0, and then this 1, 2, 3, 4. It looks like this max, the horizontal position this max is happening is at 4. So we would say, oh, if this was the graph, we would say that the answer is 4 for this part. And then with the output value, so what do they mean by output value? So if I plugged in 4 into the function, what is the value of the function, or what is the y coordinate, the height of the function when x equals 4? So we would look here and say, okay, well, it looks like, let me see, 1, 2, 3, 4, 5, 6, maybe 6, right? So the height along your output value is the height that the function is at that x equals 4 value. Okay, so I go up 4, and then I trace back and see how tall it is on the y-axis, right? Okay, then the same thing with the local, oh, actually, I mixed it up. These should be down here for the local maximum, if this was my picture, okay? So the local max would be, x equals 4 and 6, if that was my, okay, the local min, because it's a minimum, then it would be happen here. So I would say 5, 6, 7, 8, I will say it's about 9. So the x value of the horizontal position it's in is 9. And then the value of the function, I would just say it's like 1, like a height of 1. It's because the height that it hits its minimum at is like 1. All right, so that's, if this was my function, that's what it looked like. That's not our function. So in this problem, we have to look at this more complicated function. So let's see how we would do that. So to graph this function, we're gonna pretty much we're gonna learn some techniques on how to graph without using a graphing calculator, but this says use the graph. And right now we don't know how to graph yet, so we can use a function to help us graph. Now this is not that great, because you'll see in a minute that this graph is going to be very hard to view, and I think the hardest thing is picking a window, zooming in or zooming out on the picture to get the best picture. Like I mentioned, we want to look for the hill. We're looking for where the hill is. That will be our local max. And we're looking for like where a valley is, and that will be our local min. And so we might have to search around after we look at the graph of this. So what I do is I go to class calc graphing calculator. So here's the internet. If you type this into your URL address bar, it's classcalc.com/graphing. That's a dash calculator. Okay, and I just press enter, and I think you don't have to sign up. It's free. It's a free graphing calculator. So what I did is I entered in that equation that they asked us to graph, and it's pretty straightforward. Let me show you how it's done. I just click on this and these lines. I already have it graphed above, but that's just to help me. I just remember what it is, but I just F parenthesis X parenthesis equals 2x. Now this is a tricky one, so I have to use, I do shift 6. It's a little caret symbol, which means it's like a little upside down V. And then that gives me the superscript of 3, and then I press my over arrow, and then minus 27 X, I do the shift 6 again. That's an upside down V, a caret, and that gives me a superscript of the 2. And then I go over arrow to get out of the superscript, and then I do plus 48 X, and I just use the regular X on on the keyboard. Okay, and now I have my equation. So I'm going to erase the first one so it doesn't get confused. And look, it graphed the equation, and it's graphing it in this pretty blue color for me. Already you can see that it's really thin. And if I probably zoom a little bit more in, you can see how there is that hill looking thing. And if I see, that's the problem. I can scroll in and out of this picture, and it's not that pretty, but you can see that it kind of goes up to a peak, and then it looks like it's going down to a minimum. Possibly if I follow this down, I'm probably going to find that min value. So I look here, and then my map, so it tells me where it's happening on the x-axis. That's the first value in parentheses there is the 1, and where it is on the y-axis, where this max is happening on the y-axis, and that's the 34. So that's our max value. So let me go back to our problem. So for the max, local max, I'm going to do the x value was 1, and the output value, or the function value, or the y coordinate when x equals 1 for that function was 34. Okay, now we need to find the min. And so this is kind of really hard, because look, if I make things smaller, you can sometimes I have to kind of just drag. I have to pick up and drag around so that you can find the min. But look, there's where the min happens. But that's what makes this hard, is because scanning rules, I have to scroll, and I have to kind of move around, and I just click and hold, and then I just am able to move around the screen so I could see a particular part of this graph that I want to. But it's really hard, because maybe I could make this like my max screen, but it's really hard because you can't really see the max and the min on the same screen and actually see that that's what's going on. So we're going to be learning later in the class how we could find these. Well, you'll learn later and how to graph and find these some important parts on the graph without having to kind of search around. and zoom in and zoom out very much, because I just wanted to show you. So here's the min value, and you can see the graph is coming down, down, down for a really thin valley. And then it hits this min value, and the x coordinate is 8. So I go back over here, and the value that I want to plug in here is 8. And I think that the y value, so let's go back, the y value when the function value or y value when x equals 8 is negative 309. So that's what we want. And here is negative 309. Okay, so this was 8, x was 8, and negative 309. Now, let me just talk a little bit more, like when I first saw this, I first just graphed this and pressed enter. Like I think I saw like something like this. I saw something like that, and I could not see where I couldn't recognize, really where the, if you see something like this, it's kind of hard to see where the valleys are and where the peaks are. So you kind of have to, like I said, you have to move around and change the window that you're in. That way you can kind of move to the left and move to the right to kind of figure out where those min and max are happening. And sometimes you have to zoom in on the picture. And that's what makes this really hard. Some of these graphs, especially this one, it doesn't seem to be it's not easy to see both the min and max in the picture. And we don't really see it until we kind of zoom in quite a bit. Now, even with a small graph like this, I can't really see much. See, it doesn't even look very much like a hill, but I know what I'm looking for, and I know that it does look like a hill and followed by a valley. So it just takes a little bit of work sometimes, and you might have to scroll way far to the left to see something of interest, or way far to the right, but hopefully most of the time, I think most of these equations, they try to make it so that the important information is kind of close to the center of the graph, which is the 0, 0, which is this case. But anyways, that is looking at a graph, and later on in mathematics, you will be able to find these crucial points of your min and max values without looking at a graph and without having to kind of search around for it. And you're not going to have to look way to the left or look way to the right, or you're not going to have to do any of this searching. You'll just be able to find it algebraically later on. All right. Have a great day. Talk to you later. Bye.